Good morning, students. Welcome back to your mathematics class. Today, I will be starting a new chapter of your course syllabus. What is that? That is chapter 15 of your NCERT textbook. This is what? Probability. Whenever we talk about probability, the first thing comes to our mind is occurrence of any event associating with a random experiment. You have already discussed this particular topic in your earlier classes, isn't it? Now, in this particular class, I will be still explaining you about the term probability, the theoretical definition of probability you are going to use in this particular course, and few formulas and few terminologies will be explained here for your better understanding. Okay, I will be providing you the solution of the one exercise which is present in your syllabus. Okay, that is 15.1. Later on, you will get the PDF material for that. So, continuing this video session, let's start. What do you mean by probability? Okay, I know you are knowing all of it because you are thinking, oh, we have already studied about probability. Still, children, I want to say that you are calculating probability means you're finding certain probability of occurrence of any event, means you are finding out the chances of happening occurrence of certain event which is associated with a random experiment. I'm again repeating this word, random experiment. We are not calculating the probability of an event whose chances to occur is known to us. You must have seen from the very junior classes, you are discussing about probability or calculating the probability of few particular examples, few particular random experiments. What are like they? Say picking a ball from an urn, or maybe you are drawing a card from a pack of 52 cards. And the most common example is what? Yes, tossing a coin or rolling a dice, isn't it? And you have done so many problems for that. Why can't we find out the probability of any experiment whose result is known to us? Say, for example, you have given a correct answer of all the problems given to you. Now you're very sure about it. Yes, that I am going to achieve full marks for that. Okay, or your science teacher is telling you that, look children, these are the two chemicals, and when we are going to mix them, we are going to get this particular resultant out of it. Say, for example, in a chemistry lab, you are going and you are doing certain experiment. And for that, you are very sure of it. Correct. That if acid plus base is going to mix, you are going to get always salt and water. These type of experiments are known as deterministic experiments. What is the difference between random experiment and deterministic experiment? And the probability, the calculation, this entire theory is associated with which type of experiments? That is an important point to learn about. Okay? Deterministic experiments. Here, when we know what is going to happen in the next, what is going to occur tomorrow, we are not at least actually bothered about the calculation of the chances, isn't it? Fine. But when, or tossing of a coin, I'm going to toss a coin, I know. I'm going to roll a dice, I know. I'm going to pick a card, I know. But I know what can happen. I know these are the options. These are the outcomes. For tossing a coin, I'm going to get either head or a tail. For rolling a dice, I'm going to get 1, 2, 3, 4, 5 or 6. But actually, what is going to happen in future after rolling or tossing or drawing or picking, that is not known to us. Fine. So this is known as, this type of experiments, this type of activities are known as random. Random activities, random experiments. And we are, children, interested in calculating the probability of such thing. Correct. We are calculating the length of any particular, say, object, okay, and we are calculating the measure of the angle. We are measuring the mass of any object. So we are always interested in measuring. We are always interested in measurements. So why not to measure the chances of occurrence of an event? Fine. So this urge of calculating the occurrence of any event has raised up in 16th century, and we are so much facilitated with that particular calculation method, and some of it we are going to start today. We are going to study about how to measure the probability of occurrence of any event E associated with a random experiment. There is a random experiment and I'm interested here in finding out the probability of that particular event. And as you can see, I have written in the board, that is theoretical definition of probability of any event E. So the formula you have earlier also used, and today also we are going to continue with the same syllabus, same formula, that is P of E. The notation tells us probability of E. The notation tells us probability of E equals to number of outcomes. Outcomes means the results which is coming out favorable to event E. This favorable word is very important. Why this favorable word is important? Because I need to see that which are the conditions favoring to me after a certain experiment. Correct. Say for example, after tossing a coin, I'm going to get head. So the result is head. And how many outcomes can be there? That is 2, head or tail. So total number of possible outcomes is 2 in the case of a tossing of a coin and getting a head. So getting a head is an event associated with the experiment tossing of a coin. Tossing of a coin is an experiment I'm talking about. Rolling a dice is an experiment I'm talking about. And occurrence of an event and happening of an event is getting 1, getting 2, getting 3 or getting 6, or getting an even number or getting a set of odd number. Fine. So in the pack of cards also the same thing happens. That getting a spade or getting all the black cards or the red cards. So favorable. I hope you understood the meaning of this. What are the outcomes which is favoring my demand of this particular event E? About total number of possible outcomes. Am I clear? So this is the one which we have to use throughout the syllabus, the particular theoretical definition of probability of any event. Okay. Next you can see the range of probability. This particular word is written here. Range. What do we mean by range? See, you're giving certain examination, and when you go back home, you tell the result of your exams. Say you're telling your mother, I got 50 or I got 36 or I got 83 or 95. The first question which comes from your parents out of, am I right? Yes. The first question comes out is out of, that means they are assessing you, that how have you performed in the particular exam. Correct? That out of word is very important here. Say here in the denominator also, total number of possible outcomes. So, in that case, if a 100 marks examination you are giving, if you have performed so well, you will get 100 out of 100. Okay, you will get 100 out of 100. So in that case, it will be what? A full percentage marks, 100%. And if you have not done well, you have not written something, say for example, my God, when I'm saying this one, you receive 0. Sorry for that, you got 0. So 0 out of 100. Okay, and if I'm going to divide it all along, then 100 by 100 is 1. If I'm going to calculate the ratio, say 100 by 100 is 1 and 0 by 100 is it's 0. Fine. So what I want to say, that whenever you're calculating something, some favorable outcomes by total number of possible outcomes, in this case, in this particular case, I want to see that the maximum value of the ratio, as you can see that this is a ratio. No, this is a ratio. So the maximum value of the ratio can be 1 and the minimum value can be 0. And can you ever, if I like you so much, but still you're my child, I love you so much, but I cannot still give 105 out of 100. Fine. And my God, if someday I have to give you less than 0, that I cannot imagine. I hope, not to discuss all these things. Fine. So it cannot go less than 0. Say you have a bag and where you have all blue colored and red colored balls there. Fine. And I'm telling you, please get me a white ball from there. So what will be your quick answer? Mom, there is no white color balls. So I have blue and red. So I would say then, can you just tell me the probability of getting a white ball from there? So you will say, Mom, that's 0. There is no chance of receiving a white ball if I'm willing to pick up a particular ball from that urn. Isn't it? So that is what? That is 0 chances, 0% chance. That 0% chance is the minimum value of probability of any event can receive. The minimum value probability of any event can receive. I hope it is clear to you all that the maximum answer, if somebody is getting answer 10, probability is 10, that means must have a wrong idea about it. It cannot go beyond 1. And if somebody is saying it's -1, so please, I'm sorry, it cannot go below 0 also. So the maximum value 1, the minimum value 0. Please do remember this one. Correct. Now because along with this, I need to say something about it. Okay. I have here, as you can see, that probability of E plus probability of not E is 1. What about this? Probability of E, probability of not E is 1. Not E. That means if E is the probability of calculating the occurrence of any event is E, that means I am going to calculate the complement of occurrence of E. That means I am going to calculate what will happen when there is a demand of calculating the probability of E complement. That means anything other than E. Anything other than E. Listen carefully this one. Please do focus on this word. Complement of E means not E. Correct? So if a urn is having blue color ball and red color ball, so getting blue ball is something and not getting blue ball is another thing, isn't it? Not getting blue ball means you are going to get red color ball only, because you have the another color in the bag is what? Another color in the bag is how much? Not how much, is what? That is red. So getting blue ball is something and not getting blue ball is another calculation. Okay, so I will remember from now that probability of E plus probability of not E is 1. We will set certain examples also, we will find in the examples in your NCERT textbook, and you will have certain problems also in your NCERT textbook. We will discuss later on that how to calculate and how to use the formula, that is formula number 3, this. Okay, so now the last one but not the least, here you can see all of you that I have written something here, probability of shear event and probability of impossible event. What about that? Shear event. Shear event. The name itself speaks something for itself. Fine. So that means what? If you are very sure what you are going to get, then its probability is 1. As I said about the MCQ questions you are attempting, and you know all of them going to be correct. Correct. So, for example, you are rolling a dice, and I am going to give you a problem. Please calculate what is the probability. Please calculate the probability of getting a natural number. Getting a natural number less than equals to 6. So you will say, if I am going to roll a dice, then I will be getting 0, it's natural number, so it's beginning with 1. So I am going to get 1, 2, 3, 4, 5, 6, stop there, because it's less than equals to 6. So that's all we have actually. So if I am going to give 1, that's okay. 2, it's okay, favorable. 3 favorable, 4 favorable, 5 favorable, 6 is also favorable. So all 6 are favorable. Out of 6, so 6 by 6 is going to give you 1 as the answer. So probability of shear event, please remember children always, the shear event, probability of shear event is always 1. And the impossible one, that is the impossible event, which is never you're going to receive. Say for example, head and tail. After tossing a coin, you know, either you're going to get head or you're going to get tail. Are you going to get 1 after tossing a coin? No, you are not going to receive that. Or if I will say the probability of a natural number, getting a natural number equals to 7 in a roll of a dice. Probability of getting a natural number 7 in a roll of a dice. So you will say, oh gosh, it is impossible, ma'am. I'm not going to ever receive this one. I have only 6 phases in a dice and they are 1, 2, 3, 4, 5, 6. So that's going to be an impossible event whose probability is always 0. Say for example, in the upcoming examination, what is the probability? Make sure what's the probability of getting full marks? That's 1. Okay, please prepare yourself like that. And getting, oh gosh, I don't have to give that. That will be 0. Fine. So in this particular session, I explained you certain terminologies and formulas and the theoretical definition of a probability. It was an introductory class to probability, and I will be sending you some materials regarding this. You have certain MCQ problems in your syllabus, so based on this theoretical explanation you might get problems, and you have a fill in the blanks in 15.1. in the very beginning you have a fill in the blanks, and I'm sure after this explanation you will be able to do it by your own. Though I will be sending you the solutions, but still I'm very sure you're going to understand, you're going to get this particularly very well. One more last thing I would like to explain you, that is what about equally likely or equiprobable events. Please look at here, equally likely, one more term. So equally likely, the name itself defines itself. If probability of getting head is half and probability of getting tail is half, so they are equally likely, 50-50 chances. Correct, we often used to say, and that means they are equiprobable. Their probability value is equal only. Getting 1 is same as getting 2, getting 3, getting 4, getting 5 and 6 also. Because it's a fair dice, it's a fair game. For a fair dice or to be held with a fair game, it's always same dear. Fine. So remember, equally likely events means the events which are getting the same probability values. Okay. Say for example this one, as I've said, there are so many examples in front of you. So many examples are there in your book. So please go through that. And this is all for today. Please go to the PDF material also. What I'm sending, the definitions are made very clear there. So that's all for today. Have a good day.